Yeah, okay, here we go. I thought for a presentation, just to get things going, I've been doing a lot of Google Cloud the last few months. A few years ago, I was doing AWS. I've done like a lot of Unix over the years, various different platforms. And so in the process of getting up to speed on Google Cloud, I've learned a lot. And so by extension, I thought I would sort of give you a very brief introduction to the platform. It's a complicated subject, but try and help you get to speed as quickly as possible. So at a high level, we'll do an overview of Google Cloud. We'll look at Google's Colab, which is like a notebook-style tool for doing cloud computations. We'll look at their deep learning AMI, which is a very quick and easy way to build up a deep learning machine learning project. We'll do a demo with the TPU, which is Google's tensor processing unit, which is one of the fastest machine learning platforms in the world. We'll do like an easy demo and then an advanced one. And then finally, we'll go through some various random stuff that I've hit while trying to learn the platform, and hopefully save you the time of messing with that. So what is Google Cloud Platform? Basically, this is Google's tools for building Google. Many people think that Google has this whole set of secret libraries and secret sauce, but the truth is that whenever you log into the Google Cloud console, that's basically 95% of what Google engineers are actually using every day. So if your long-term dream is to work for Google, just learning the Google Cloud Platform is actually the fastest way to get there. There's no secret sauce, to be truth. As a result of running Google, these tools are battle-hardened, and they work at Google scale. So you can put billions of users on these things. Everybody and their brother is trying to hack everything, and so many of these security stuff has already been thought through 13 different ways. And so as a result, if you can use their platform, you can get the benefit of a lot of this work that other people have done. The flip side of this is that Google, most of the projects are set up a certain way. So it's an opinionated system for building tools. This means that if you're used to doing things a certain way, and the Google system is designed differently, you're going to need to either rethink how you're doing things or try to jury rig, but at which point you're sort of getting off into the weeds. So this is something that people get frustrated about because Google doesn't necessarily let you do things the way you like to do things, but the flip side is that if you follow their process, you'll be within their sandbox, and then you get the benefits of all this other stuff. So one of the big things that the Google Cloud Platform then gives you is user authentication. So you can do one login to the Google system, and then you can do, you have one system over here, one system over here, but they have a single shared login system. And then broadly, the Google Cloud Platform is just Unix. So if you know Unix, to quote the kid from the Jurassic Park movie, you know this already, but the flip side, if you don't like Unix, then that's all it is. So there you go, you've been working. So this is the first super easy trick that I think everybody can pick up.
Is this Jupyter Notebook?
This is Google's Colab, which is very much basically Google's version of Jupyter Notebook. Google runs this, and they have even free GPUs and free TPU time, so you can run it, and up for 24 hours, you can just run your stuff free in the cloud. So if you can do basic Python, you can do this stuff. So this is all completely free to use, and we'll do a 5-second demo of it, but here we go. So we go like hello, GG, hello, we run it, runs up in the cloud, outputs the result, and there you go, print statement. A couple years ago, I did this demo for one of my talks. So this is a This is a machine learning demo. So, here, bam. So we've literally just copy pasted that code from my old project into the new one. And we will now run it. And if we scroll down, it's training a very simple neural network to do machine learning on the mnist data set. So we've just built a neural network model using the cloud, running in the cloud. It's all up there on Google Cloud, but basically you can find all this code off the internet and just run it for free without having to really, a lot of this libraries and stuff can be a pain in the butt, but this just abstracts it all the way. The second trick that I think you should know for doing this Google Cloud stuff is basically many people have already built pre-configured machines. So if you're familiar with Docker, Kubernetes, these sort of tools, there's pre-built machines. All you have to do is simply run one. So to do a good example, we will create an instance. This is the basic drag and drop, the basic interface. What's cool about this is, for example, this is Google. So we can click that button right there. And now we can make a server that has 3.7 terabytes of RAM, just by bang, 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 right? In the same concept, Google has already set up this whole marketplace of pre-configured solutions. So you search for deep learning. This is the Google default image right here. Click here. You can configure it to have a different GPU. So this is the Tesla T4 GPU that came out last month, or last fall. And then right here, if you've ever had to set up any of these libraries, right here, one-click button, no work, whatever, and you have a very nice starting point for building workflows. Yes?
What's the difference in functionality between Google Cloud and AWS? And do you have a preference, for which would be best for a server-side backend?
AWS is more oriented towards, it's sort of the commoditized version of all this stuff. AWS, I would honestly prefer Google Cloud right now. I haven't done this for last year. I think Google Cloud's cheaper for a lot of things. Google Cloud does not have as many features as AWS, but on the flip side, AWS will often give you 5 ways to do things and trying to make them all work together.
Just need one.
Yeah.
And is one cheaper than the other?
In theory, they're about the same, but I would say probably in practice, Google Cloud actually often ends up being cheaper.
Okay.
So we hit this button, and it's deploying us a new machine in the cloud. And so now in a couple minutes, we'll have a virtual machine for running TensorFlow. This is using new TensorFlow 2, which is completely bleeding edge, we'll say, but somebody at Google has packaged it all up neatly and nicely for us. We'll come back to this one here in a second. So now we'll look at the tensor processing unit, or TPUs. This is Google's cloud GPU that they've actually made themselves. It's custom hardware, but you can access it via the Google Cloud Console. They support some different data types. I did a talk last fall on TensorFlow and Swift where we went deeper into these data types. What you're seeing right here in this picture is a full rack of these things. So 1, 2, 3, 4. This is a group of 4 TPU2s. And in this whole cluster is a cluster of 64 TPU2s. And this whole thing is roughly somewhere around a petaflop of processing power. The important thing to note about this picture is that these right here are the TPUs themselves. They're like a fancy GPU. These things over here are the computers that control them. So the way you actually use a TPU in the real world is you create a controller computer, and then you have a TPU computer that's bound to that controller computer. And so then the controller computer issues commands to the TPU, and then they talk to each other over literally this cable, which is Ethernet. If you've done traditional machine learning with regular devices, the crucial difference then is you often have to deal with this whole networking layer, which adds a little bit of layer of complexity. So we'll see it here in a second how it actually all works, but that's the key concept I think you need to know if you want to mess with TPUs. We did the mnist before, just using Keras as a basic thing. Now we'll do mnist again, but we'll run it on a TPU in the cloud. The first command you'll run is cTPU up. This will create the virtual machine that's going to control your TPU, as well as register a TPU for your use. So you'll run this command. The problem with this, for doing this for a demo, is it then takes 5 minutes for all this stuff to get going. So I did it 20 minutes ago so that we wouldn't have to sit through that part. So now we're logged into a computer, which then is connected to a TPU. So then we can run, we're setting a place for the data to be stored after it gets run. Whoops, sorry. Oops. And now we will run the thing. It takes a few seconds to get going, but the local computer is talking here, and it's connecting to the remote computer. And then if we wait another 30 seconds or so here, it will all start to work together. And so now we're actually training the mnist data set using a TPU in the cloud. So take about another 10 seconds or so. And voila. So now we've done everything we did with Keras before, but we've done it with a cloud supercomputer, so to speak. It runs like a test after it does all the thing. So it's finished running. And then if we go back over here and look at our so here's the results of our run that we just did. We saved it basically to a Google Cloud bucket, which is equivalent to an S3 bucket if you're working with AWS. So it's just a little basic demo of doing machine learning in the cloud. All right, so now we'll say that the Keras demo was a beginner level demo. We'll say that that demo was kind of intermediate level demo. It's all command line, but conceptually it's nothing. So now we're going to do like an advanced demo. ResNet, or residual networks, are a computer vision network. So we're going to train it now on the ImageNet data set, which is a larger data set. mnist is about 100 megabytes of data. ImageNet is about 150 gigabytes of data. We went from 10 categories for mnist to 1,000 categories for ImageNet. And finally, the third trick we're going to do is we're going to add Kubernetes to this whole mix. So before we had a single controller computer. Now we're going to have a ring, a cluster of 3 computers that are the controller for the TPU nodes. We're going to add a batch job to the Kubernetes cluster, which will then spin up a TPU pod in order to run the whole ResNet ImageNet training demo. So, the process of actually creating a TPU cluster is nothing, or sorry, Kubernetes cluster is nothing more than running this command. So I did it already. It takes 10 minutes to run, the same concept. Then what we're going to run is this Kubernetes job file. I took basically the default from the TPU demo and simply modified it slightly. So here's where I have the data, and here's where it's going to save its results. And other than that, everything is pretty much the same. So then finally, we create this job. It's submitted to the cluster, and now the cluster will attempt to create TPU pod in order to run it. So, here's the TPU that it's spinning up to run the thing. This will take like 5 minutes, and then it will actually run the job. So I've already done this already, so that's, we'll just jump to the end results again, but this all works. Why would you want to use this process? The strength of this approach then is that the cluster Kubernetes is self-healing. So this is some other things that are running right now, and they're doing jobs, right? But we can literally take one of these servers and delete it. Wow. So that's being shut down right now. And now if we stand here and wait for a few minutes, we'll see that the cluster detects that that computer died, and it will basically restart the job. It will respin up a new machine and do the job. So, see, it's already figured out that that machine was dying, and so it created a new one. So this gives you a lot of resiliency for your jobs and scheduling, because you don't have to micromanage things. The cluster can take care of it for you. Oops. So anyway, our ImageNet will run for a while, and we'll get a set of results like this, and it will output the whole model. This one, that particular configuration or so, will take about 12 to 14 hours to run. Google, part of what we're doing is we're using preemptible TPUs. So that means that Google charges us about $1.50 per hour to run these machines. So doing this full ImageNet run then will cost you under $20. So as recently as a couple years ago, doing something like this would cost $1,000, and nowadays, basically for the price of a pizza, you can get it done yourself. So this is the current state of the art for ImageNet training in the world. And as you can see, by utilizing the methods that we just shown you, you're somewhere between the first and second best in the world for training on a public cluster, on a public cloud, using literally off-the-shelf tools. There's nothing more fancy than what I've shown you. So the remainder of this basically is just some random Unix stuff I've run into doing all this stuff. Most of the Google Cloud infrastructure is based around Python 2. So if you're used to using Python 3, you may have some fun getting your workflows working in the cloud with that whole system. Most of the Google Cloud infrastructure is built around Debian, but then a lot of the deep learning stuff is built around Ubuntu. As somebody who spent a lot of time with Unix in the past, one of the quickest ways to go mad is to try and troubleshoot something in between two ever so slightly different versions of Unix. So my basic advice to you is like, make your development machine literally be identical to whatever running on the cloud, and then that way there's no way that libraries can come in and stab you in the back. Some of the pseudo tools are kind of weird with Google Cloud, so that may not all work the way you're used to doing it. So just FYI. And then fundamentally, all these Google Cloud tools are scriptable and API-able. So to use the example before of to use the example before of creating an instance. Okay, sorry. What you can do then is basically copy paste this sort of thing right here, and it'll give you literally the command. So then you can just copy paste that and say you need a new server, just paste it in your command line and fire it off. And the same concept, you can modify some of the parameters, say if you only want a certain type of thing or whatever, you can just find that parameter. So literally everything in the Google Cloud Console is scriptable like this. There's that little rest button or whatever someplace. So anything you can do, basically then it's trivial to take it and convert it into a script or a cron job or something to that effect. I've not demoed TensorBoard, but that's a good tool for tracking machine learning jobs. Bigtable is sort of Google's version of SQL. PubSub is a pattern for doing event scheduling and stuff. Beam is kind of the new hotness. I don't know if many people have seen it, but basically it takes sort of these first two concepts and combine them together. So you have a very sophisticated sort of batch processing pipeline for doing data. So if you're dealing with lots of data processing and batch processing, I think you should know that. Stackdriver is Google's tools for demoing, for dealing with logs.
Dogs?
Yeah, tracking, make sure your logging is running correctly.
Oh, log, I said dogs.
And then maybe I'm just a mobile programmer and I think this is cool, but they have this little app that will let you connect all your servers. So let's take our TensorFlow machine that we started before and we'll delete it. And so now, wait a few seconds. And so our server is being deleted, which is, I don't know, that's cool to me, if nobody else. And then, yeah, Google has more advanced tools, computer vision tools. You can ship a picture up to the cloud and it'll tell you what's in it. They have NLP, language tools. You can ship text up to the cloud. It'll attempt to make sense out of it. AutoML is this new thing they've got where basically you can push data up the cloud and it'll try to find the best models, so you don't even have to understand how all this machine learning stuff works. So this is all just the very cutting edge sort of future stuff. Yeah, so if you've enjoyed what I've done here, basically you can go through the TPU demos. These are all like different demos that you can do that are, slightly modified versions of what I did with ResNet earlier, but these are all should be runnable. And if you're interested in this, I would highly recommend you play around with that. Google Cloud, one second, has like a setup right now where if you sign up, you get $300 in credits for free. So all the demos I've done today can be done for like $10 to $15. So at the very least, you could put $100 of their money into using their platform and, at least learn how some of the stuff works.
Yeah, follow up with your talk, are there any good PDFs or books or e-reader, like background material, or is it so new that no books are written? Like, if there was like a bibliography for this talk, what would it be?
There's a couple good books out there, I would say, from like O'Reilly, but to be honest, if you run through this whole set of logs, pretty much everything I did today is in here somewhere.
Okay. Well, I want to learn more, so this is very interesting to me.
Literally this is the mnist demo I did, which is, here's exactly how to do it.
So you think the online documentation is enough?
Yeah, I would say
Okay.
so. This is ResNet. I mean, literally, I just
Okay.
copy pasted this demo and ran it in the console. So.
Well, could you send me this URL on LinkedIn?
Sure, I would be happy to. But yeah, that would be my suggestion for how to get going. So yeah. Anyway, thank you all for coming.